All right. Thank you for showing up, everyone. Today we're going to be talking about local LLMs with Ollamma. So this is what we'll be covering today. We're going to be covering over just an intro to local LLMs in general, and then we're going to go over what is Ollamma specifically. We'll cover the install setup of how to get this working on your actual machine, as well as different models you can configure it with. And then after that, we'll just see if you can use Ollamma like normal cloud providers. So you've heard of different LLMs that have been very popular in the last few years. I'm sure you've seen these should look familiar to you. We have ChatGPT, Google Gemini, Grok, and Claude. But you probably use these, but you've noticed that like there's various problems about these cloud providers that they have. Sometimes you want to put in your private data, like you want to like analyze a data set that you might have, especially for like bigger companies too. They'll often have be having to deal with healthcare records, things like that. So they cannot plug it into these consumer AIs because once they're fed into the local LLMs, then they'll actually be saved most of the time. So it depends on the provider for sure, but ChatGPT and Gemini, those two specifically, they definitely save all your data and they'll have it in for safekeeping as they train their models. So because we don't trust all these AI cloud providers with this data, we will be using local LLMs to implement some of these things that you want to have. So if you don't trust big tech with your data, this is what you should be using. The benefits to it are many actually, but I'll start with the big obvious one, privacy. All of your data stays local. So if you're like doing anything with like RAG, anything, we'll actually have a workshop too in the future about that. But if you're working with like sensitive files, sensitive code, things like that, all your data stays local on your machine because it uses your GPU, your CPU, your VRAM to actually run the model. So that means that when you're putting in your data, it's not like being sent to any cloud server, nothing over the internet. And also that leads me to my second point, which is you can use these without the internet. So like if you're on a flight or something and you just have these like on your machine, you can use them without the internet. And that's especially good. Like if let's say like one of these popular providers like goes down at some point, that would be very good for you. Customization, this is much more advanced. Frankly, I'm not at this level myself, but if you are smart enough and you know how to like modify the code and the model weights, you can actually like fine tune these LLMs. Some of these too, you can actually like train your own LLMs if you're smart enough to do that. And you can train it on your own custom data, custom needs, and basically tailor it to answer it the way you want it to. And finally, token limits. I mean, you've probably like, especially like these days, it's a bit better with the token limits, but like, especially the last like 2 years or the first 2 years that ChatGPT came out, you like use it a bunch, and then at some point it like rate limits you or like downgrades you to a lower plan. If you use local LLMs, then it won't do that at all. It'll be that one model's on your PC. It will be you'll be staying on that model as you use it. So the only thing that really matters is like your actual hardware. Like if your hardware can keep running it, then you can keep using it as long as you'd like. So obviously we're gonna go over one problem about using these. RAM, I'm sure you guys have heard of it. Uh, it's freaking expensive right now, and it's not gonna get better anytime soon. So obviously, if you're wanting to use these local LLMs, you need a ton of RAM to run like the really top of the line models. But of course, with today's goal is we're just gonna use like the smaller models. If you guys like have stronger computers, you feel free to download like the bigger ones. But for today, we'll just try like the 4 billion parameter, 1 billion parameter models just to make sure that like it actually runs on everyone's machine. And yeah, this is just a story that happened recently that I thought was interesting. OpenAI is using 40% of our global RAM in the future. So now we're going to get into Olama and like what it actually is. So like, have any of y'all ever heard of what like Docker is? Yeah. What do you know about Docker? Hmm. Yeah, basically, like I would describe Olama as like the Docker for LLMs because Docker, like if you've ever made projects, like there's tons of dependencies. Like it's not consistent when you have a team project and you need many developers to collaborate on the same thing. Olama is basically like that for LLMs. you have one platform. It's like an inference engine too. So you can plug in models from like many sources like on the internet that are available, all the open source ones. And Olama is like generally I think right now the standard to run many of these local LLMs. There's a couple other providers you can use as well, but Olama is like one of the easiest ones to do. Yeah, so you could check out platforms like you can go on Ollamma.com itself and see many of the models, but you can also go on Hugging Face. There's a couple other model libraries that like have like a vast store of all of them. So now we're gonna see the install setup process. So first you can go to Ollamma.com and then there's like a download button at the top right. You can download it for your operating system. And then after that, we'll go over the models. And by the way, we do have another workshop. So this one will build upon what we're covering today. The next one will cover React. That will be this Thursday, March 19th. It'll be 7 p.m. online. So make sure to attend. Are any of y'all doing it right now? Let's see. So it should be Olama, and then you can download it from this link. So just pick the operating system of your choice, and then just go from there. I'll go ahead and continue. But yeah, I know the internet's a little whack right now. So now we're going to go into different models that you could download because there are a lot, especially now. If it was like 2 years ago, there was a lot less, but now there's like hundreds of models to pick from. So these are just some of the most popular ones that exist out there. So obviously there's DeepSeek, which was the OG NVIDIA stock killer last year. That one was really good. But since DeepSeek came out, there's been like a flood of new ones that came out, and many of them actually it did force like ChatGPT. They forced ChatGPT to actually open source a couple models. So they have a 20 billion parameter one. They also have a 120 billion. It's called OSS. But there's also Quen. That's the one I'm using right now. This one's created by Alibaba. They released some new models, like it's the 3.5 family 3 weeks ago. So those ones are really, really good at like reasoning, coding, thinking, like all of that stuff. And especially since like a lot of us are computer science majors, that has a very good use case for us. There's also one called GLM. This one is by ZAI. They're also one of the newer ones. They have one called 4.7 Flash that came out. That one also lets you do like lots of coding and stuff, but they also do like image generation and like multimodal input. So these are just like some of the ones that are recommended depending on your hardware specs. So if you're doing light with your VRAM is the main thing with this. So if you're doing like a lighter model, you want to get like one of the models that are 4 billion parameters or even less. So for those, I have Llama 3.2, Gemma 3. There's a lot of other ones. I'll go over those. But if you have one that's like 16 gigabytes of RAM on your PC, you can go for a bigger one. So here, same thing. We have Gemma 3, but that's 12 billion parameters. We have DeepSeek R1, 14 billion parameters. And many of these model families you can get in smaller and bigger configurations based on the size. And for high performance ones, we have Quen 3.5, 30 billion parameters, GLM 4.7 Flash. Those ones can go, again, 30 billion parameters or higher. Those ones you'll need like 20 to 32 gigabytes of VRAM easily, at least. Right. This is an example of what you'll have. I'll go ahead and skip over your console. This is an installation process for Gemma 3. And then we have one for DeepSeek R1. So these are the key commands you'll be using. So once you install it, just use the first one, Ollamma dash dash version, to make sure that it's installed properly. You can use Ollamma space list in your terminal, and you can see which models you have downloaded already. And then after that, you can use Ollamma pull, and then whichever model you actually want. So I'll demonstrate a couple of those too on this laptop. And yeah, we'll go from there. Okay. Does anyone have any questions so far in the audience? I see we have a couple people who joined the Zoom too. Welcome. Brian, Camille, welcome, welcome. Let's see. So I'll go ahead and share one that you could use. So this one is Qwen 3.5. This one comes in many configurations. We're going to go ahead and just download a lighter one for this demo. Yeah, does this share your whole screen? Yeah. Okay.
So,
Thank you. So here we're going to be installing a new model. We're going to be calling it. So here I'm going to just check that I have Ollamma on here.
um, should check version.
Wait. So here I'm going to be checking it. Here we already have it installed. So we have 0.17.7 on this one. And then after that, we can do our list right here. We have a couple that are already installed. We'll get one more new one. Let me check the chat real quick. Oh, okay. So we're going to be trying a new poll right here. So the way you do it is Ollamma space poll and then the one you want to get. So in this case, we want to get Qwen 3.5 and then we're getting 2 billion parameters because that's a lighter one. So we do Qwen 3.5. There should be no spaces when you do it. Colon 2B for 2 billion parameters. And then when it's installing, it should look something like this. The school Wi-Fi is weaker, I believe, right now, so it may or may not install in a timely manner. If not, we'll just use one of the other ones. All right, and once you have it installed, we're gonna see like ways you can use it. So this is what your interface should look like roughly. It'll probably be like all white at the start because of light mode. But yeah, once you have it, there's also these settings you can do. So in the future, if you decide to do like other projects that are outside of it and you want to use the API, this is like where you would check it. So for me, I use Windows. This would be the file location for me. You can find all the models in this location. This should be the default. You can like turn up the context length all the way up so you could use it on your local host. And if you want, you can also create an Ollamma account, and that allows you to use cloud models that are available as well. So, for example, if we go back here, I can go to GPT, OSS. So let's say your hardware isn't strong enough to run some of these models. Like, for example, if you want to run the 120 billion parameter one, this one is 65 gigabytes of storage, which is a lot. That's like a massive video game. So if you cannot run models for whatever reason, you can run it in the cloud, GPT OSS 120 billion cloud, and then it would allow you to run based off of like API keys you have. Let me check the chat. Okay. Yeah. So the way you would need to do it is to create an account. For today, I'm not going to demonstrate that because we're just doing the local models for today. But if that's something you're interested in exploring, you can sign in, make an account, and be given an Ollamma key. Okay. Is anyone in the audience in our Zoom audience doing this with us today? Or just following along? Okay. Any questions out here? Y'all? Right. This is an example prompt you could do. So just like, you're creating a nursery rhyme about llamas. You can also use it to like say code a Flappy Bird game in Python. And in the future, if you like have files and stuff, depending on what you could get, I'm going to show an example. So the one I use is 3.5. If you're checking out these models, you can see the input that it accepts. So for this one, since they're a bit of the heavier models, you can actually do multimodal input here. So you can see that it has text for your text based prompts, but it also has images. So depending on how good the model is, you can actually put in an image, for example, and say like, oh, you put in an image of, let's say, a horse, and you say, what animal is in this picture? And it'll be able to actually look at the picture and give it to you. And then, yeah, it would just be whatever image you put in. Some of the models, they'll only have text here, so you have to like watch out for that. But apart from that, that should cover everything about inputs. And yeah, that should be it for this workshop. I'll go help out anyone who's like trying to install anything on their own. I'll go back on the Ollamma website. We'll take a look at some other models y'all could get. But yeah, that's the general setup process for the entire thing. Let's see. Can we go back to terminal? Let's see. Oh, bah. Oh yeah. Oh yeah, that's bad. How do you command Z right to stop it?
Yeah, but it's or control C.
Interesting. Okay. And then Ollamma. Okay. Do y'all see the Ollamma screen, by the way? For those on the Zoom. Oh, we do have a question. Okay. So Brian's asking, what laptop or computer you recommend for installing these LLMs? I would say like it would be the opposite question. So based on the computer or laptop you currently have, what LLMs could I install on it? So the way I would check that is in general, this does take some research. It's not that bad, but a big help is look at this. In general, you can take a look at the context window that it has, as well as the requirements for the storage and the parameter models. So general rule of thumb is if it's 4 billion parameters or less, it can run on basically every hardware. If it's between like 4 billion parameters and 20 billion, 30 billion parameters, you probably need something more mid-range. And anything that's like 30 billion parameters or higher, you're going to need a lot of spec'd out computer, especially on RAM. So I'll give you an example. Let's see. So for example, if I wanted to run, here's a really light one. What I would do is just go in like Google and type in whatever model you want. So for example, for us, I'm going to do Gemma 3 1 billion parameters since that's really light. Look this up. This is what I do every time I install it, so I have a really, really good idea. So this one's super duper light. So about 2 GB of system RAM. That's very light for a local LLM. 1.5 GB VRAM. Yeah. Hmm. Yeah, yeah. Go ahead.
Parameter list, but one thing that also matters is the amount of the amount of time it takes for the model to do the inferencing. So if you want to have a fast model, something that answers as soon as possible, you don't want to push the limits. Because something like an 8 billion parameter model might run on, for example, a 16 gigabyte
RAM
RAM
PC.
PC, but it will be significantly slower than a 4 billion parameter. Example of that, if you have a 5090 and you're running an 8 billion parameter model, that's going to take around 50% of your VRAM, even less. It's going to take less than 50% of your VRAM on the GPU itself, but it will run significantly smoother than a 30 billion parameter that is pushing it to the limits because it's not doing as much thinking. So it all depends on the context you're trying to use the large language model. As if speed is priority, go smaller always. If accuracy is more important, go the bigger model, but you will lose the what do you call it?
The
You
bigger
will,
models,
yes,
you lose speed
you
and
lose speed. It's like you can't have both unless you have good hardware.
very well said. Let me just check the chat real quick. So Brian, yeah, Sarush went over it a bunch. Downside of using lightweight LLMs. So let's say for us, computer science majors, right? We do a lot of coding, so this would be a big application we would use these LLMs for. So let's say I was using Gemma 3 1 billion parameters, right? Then if I had like, let's say a giant code base of like 1,000 plus lines code, I'm making my um like React web app, for example, then it'll have less like smaller models typically have smaller context windows, as in it can remember less of your chat. So if I have 1,000 plus lines of code in my React project, then it will hallucinate sooner. As in, I ask it a bunch of questions. I add like, let's say, oh, make the website like green or blue or something, and then I ask it like 10 other questions. And after like 30 iterations of that, it will forget like what you said at the start. Versus with bigger models, here's one that came out that's really good recently. Let me see. So this one came out, I believe, yeah, 1 month ago from what it says. This, I tried out this one, the 32 gigabyte GLM 4.7 flash with Q8. This one is extremely good for coding. So going back to my example, like if you were making your Flappy Bird Python game and it became a really, really big project, you have a bigger model, it can handle much more of it. You can ask it back and forth it much more. Versus if I had a smaller model, it would like I would say, hey, can you make the bird like fly slower or something? And then because it doesn't remember as much of the code base, it starts hallucinating more. I hope that like answered your question a bit, Brian. Can you demo your LLM you installed on your laptop to see what's their capabilities? Yeah. So I'm not using my laptop right now. I'm using someone else's, but yeah, we can see if we can demo that right now.
Easy.
Bill, yeah. So just for context, this one is a MacBook M2 Air from 2022. So this configuration has 16 gigabytes of RAM and M2 processor. Can everyone in chat see the Ollamma interface? Just a thumbs up. Okay, perfect, perfect. No. Let's see. Can you guys see the actual like the Ollamma GUI? Just the website? Let's see. 1 second, y'all. Let me see if I can fix this. We shared. I'm gonna try to share it again, but then the whole screen.
Hmm?
I'll try to share the
Uh,
entire screen. It's just
yeah, just share screen desktop one.
okay. Cool. Can y'all see like the Ollamma GUI for those on Zoom? Yes. Okay, perfect, perfect, perfect. So this one, we're going to do a demo. This one is 4 billion parameters for Qwen 3. I'm going to go ahead and do an example prompt. So let's just say I'm going to go back to our Flappy Bird game example, create. Can those in chat, or I guess those in person, either one, just like ask like what features would you guys like to see in this like game? I'll go ask the model to prompt that. Oh, we want to do ping pong instead of something simple. Yeah, I'll do Flappy Bird. Do what make the bird. What color do y'all want the bird to be? Pink. All right, make the bird pink. And let's add a giant. Wait, is your thing wait, is this thing like lagging? Let's add a giant monster. No, no. Chasing the bird as you play. The the
I like
bird does not actually die to the monster, but the monster will be chasing it the whole time. Flappy Bird is also a hard game. So make the gravity very low so it's easy for people to play on it.
um
Yeah. And then my final ask would just be make the entire project in one file so that it is easy to just post it. It's completed. So here's the 4 billion. This is just an example of like how this is a MacBook M2 Air from 2022 with 16 gigabytes of RAM. For HTML, CSS, JavaScript, yes. So for some of these models that we have, I wonder if the people in is it lagging? Let's see. Okay. So here, what you can see is many of these thinking models, the reasoning models, it will have like what are called thinking tags. So when you prompt it, before it gives you the actual response, it will go through this like thinking process. So depending on the model, like Sarush brought it up earlier, if it's a bigger model, it'll spend more time thinking. If it's smaller, it'll spend less. But you can actually get a preview of like the way it thinks and how it like tries to process your request before it actually gives you the output. So like, let's say when you're coding this Flappy Bird game, for example, it does something really wrong. So like we once it outputs the file, I like test it in the browser and I'm like, bro, I hate this bird. It's like too big. It's like it's not the right shade of pink. Like for like examples, if I do not like the way that my code output turned out, you can actually go look back on this like thinking tags that it provides here, and then you can see the way it thought out your project, the way it reasoned it out, and then you can say, okay, please make the following changes based off of that. So it could be for like those were like more of the front end side of things, but there's also like the back end, which would probably be more valuable to us. So like let's say for example, like in Flappy Bird, the game like if you don't tap on the bird, it's supposed to like fall to the ground, right? Like let's say like it hallucinates really badly and gravity's like in the opposite direction. So it like starts flying up. You can like look back on the way it reasons it and then change it once you find the mistakes and you need to debug it. Just curious, is anyone in chat trying this out? Like on Zoom? Yeah, they're not real. It's okay, they feel real, so that's all that matters to us. Hmm. Ryan, question for you. Are your laptop specs? We could get an idea of it. You could run like some of the really, really light models if it's like weak hardware. Because like the models that are coming out nowadays, you could actually run. You have 2 GB of RAM on your laptop, storage 2 TB. Hmm. Yeah, 2 GB of RAM is very little for a laptop. That might be very problematic. Okay. Once you get your old one fixed, like if it has like even like 8 GB RAM laptops, you could run like the really light ones. So if it's like 0.8 billion parameters, you could run it on an 8 GB laptop. But obviously, the more you have, the better. Just like questions for like you two, how much RAM does your laptop have? 16? 8 RAM. Okay. Yeah. 16, like most people nowadays have either 16 or 32. Eight's like for the older ones. So I would recommend getting, again, 4 billion parameter models. You could run most of those. If you really, really want to push it, you could maybe try with the like 20 billion parameter models. Anything above that, you'll probably struggle on your hardware, but just like play around with it too. And generally, I would say for like those in the audience today, just keep in mind, keep updated on the news because new ones are releasing like every month, it feels, because there's a lot of innovation happening in the space right now. So if we had the same conversation 3 years from now, you'll probably have models that are small and could like run on smartphones. So just like keep in mind this today like would be the weakest point it would be at, and going into the future, it would get stronger and stronger for the size. Let's go back to our Ollamma and see how it's doing. Okay. I would say the other problem too with running these locally is um there is the time problem with it. So especially you're running like these smaller models that have weaker inferencing capabilities, or you run really big models that are too much for your hardware, it can take a long time to generate the outputs you want. So it is something you have to keep in mind. That is one reason you would use cloud providers. Not only do they give you the models, so for like Gemini or ChatGPT, but like they do all the processing on their servers. So that's why you get your response like almost instantly in comparison. Okay. You have any other questions, like either here or in the audience on Zoom? Let's see if this project finishes up and then if we can run it. And then if that's good, then yeah, we should be good. Okay. Okay. We'll go ahead and explore some other models while we wait. Okay. All right. We'll explore some other ones. These ones I honestly haven't explored as much myself, but there are models you could get too that are like specialized. So here's one that I'll take a look at right now. So this one, I think you have to like integrate into your own projects. It's not as like straightforward as running just the general models. So there's ones that are specialized for different purposes. So for example, OCR, that's optical character recognition. So if you have like, let's say a giant PDF of like a book, for example, and you just need it all converted to text, then you can use these very lightweight models that are specialized to do that particular thing. So you can see here, this thing is literally 1.6 gigabytes of storage. It's really small. And then you could plug in like, I don't know, a 20-page lecture slides, for example, and then you want to make it a markdown file. You can use this and models like it to accomplish that. This would be like how you would run it. You probably need to like look at some additional documentation too, but yes. There's also what was it? Oh, these are the documentation. Here's another one, vision language. So this one is more specialized for like reading images. So if you wanted to make a project like I don't know with is it RAG that you use this for?
For vision.
Yeah, vision things.
You can use it for RAG.
Yeah, you could integrate this into a RAG project. And again, specialized models. So you get like again these really, really small models that have outsized capabilities with vision reasoning versus like general models, they're more for text. Okay, let's see if the thing worked. It's still going. You know what? I think I could run on my thing actually now that you're with this. See if I can join the meeting. All right. I'm on a new,
You want stop?
yeah. Okay.